Dear students, welcome to my YouTube channel, आओ chemistry सीखें. Let's enjoy chemistry. Today, we are going to discuss an important topic of electrochemistry. The name of topic is decomposition potential. Dear students, a lot of reactions take place at the surface of electrode. The rate of these reactions are studied under a branch of physical chemistry known as electrochemical kinetics. It is the branch that studies the rate of reactions that take place at electrode surface. And today we are going to discuss two important phenomena related to electrochemical kinetics. These are number one, decomposition potential, and number two, over voltage or over potential. These are the subject matter of electrochemical kinetics. Let us start with the first one, that is decomposition potential. A scientist by name Blanc performed a set of experiments in the year 1893. In his experiments, he took an electrolytic cell similar to this arrangement and increased the external EMF gradually and measured the current flowing through the cell, and also he measured the potential across the cell simultaneously. Proceeding in this manner, he plotted current density against the potential or cell voltage. We can define current density as the magnitude of current per unit area of the electrode, that is, current flowing through divided by surface area of the electrode. Here is the shape of the graph obtained by Blanc. It is the graph having cell voltage or cell potential along x-axis and current density along y-axis. As the graph shows, in the beginning, potential keeps on increasing, but there is no appreciable increase in the current density. It is shown by this part of the graph or curve. Here, cell voltage keeps on increasing, but there is no appreciable change in the value of current density. But there is a potential. Here we can see there is a potential at which there is sudden rise in the current density, and beyond this potential, value of potential changes only by a small degree. This particular potential is known as decomposition potential of the solution which has been taken in the electrolytic cell. And this decomposition potential for that particular solution can be obtained by extrapolation of the steeping part of the curve. This is the steeping part of the curve. We can see here, this is the steeping part, and if we extrapolate, that means if we keep on extending it towards the cell voltage or cell potential axis, we get a point somewhere here. This is known as decomposition potential. Theoretically, decomposition potential of a solution can be defined as the minimum potential that must be applied between a pair of electrodes to pass the current of appreciable strength through the solution. And here are certain observations made by Blanc regarding decomposition potential. If we look at this table, it has been taken Book of Electrochemistry written by Samuel Gladstone. A lot of different acids and bases have been taken as electrolytes, and their decomposition potential or decomposition voltages have been recorded in their aqueous solution. For example, decomposition potential of H3PO4 is at 1.70 volt, whereas for HNO3 it is 1.69, and for trichloroacetic acid, it is 1.66 volt. Similarly, among the bases, it has got values 1.74 for ammonium hydroxide, whereas 1.69 for NaOH, similarly 1.67 for KOH. So what Leblanc found? He found out that when such experiments were performed with aqueous solutions of a number of acids and bases, taking smooth platinum as anode and cathode, some facts were evident. Number one, decomposition potential was almost constant irrespective of nature of electrolyte, and as we can see, it was in the vicinity of 1.70 volt. Second, he observed that evolution of hydrogen and oxygen gases took place with the passage of current at this decomposition potential in each case, irrespective of the electrolyte taken. This means when the cell potential equal to the decomposition potential was applied across the cell, there started bubbling of hydrogen and oxygen gases at respective electrodes. Now, after coming across these observations, Leblanc started thinking of the possible inferences from these observations. These observations led Leblanc to conclude that the same process takes place during the experiment in all electrolytic solutions under study, because in each case the appreciable current starts flowing around a cell voltage of 1.70 volt, and second, flow of appreciable current is accompanied by the evolution of hydrogen and oxygen gas. According to him, this is possible only when a common process takes place during the electrolytic reactions among different solutions. And what could be this common process? Obviously, this could be the decomposition of water that leads to formation of hydrogen and hydroxyl ion. And then what happens? These ions move towards their respective electrodes, namely hydrogen towards cathode and hydroxyl ions towards anode, and they get discharged at their respective electrodes, forming to hydrogen and oxygen gas. So this was the basic idea of decomposition potential. One thing would like to mention again, that throughout these experiments, Leblanc took the same electrodes of smooth platinum, though he varied the electrolytic solutions. But in all his experiments, the electrodes were of smooth platinum. So this was the decomposition potential. However, decomposition potential of solutions has no theoretical significance, as it depends on two individual electrodes. It also depends on resistance of solution, and it depends on the concentration of solution. In spite of all these restrictions, decomposition potential experiments were useful. They are of historical importance because they led path to a more important concept that is known as overvoltage or overpotential. In my next video, I will discuss about this concept of overvoltage in detail. Thank you.